Okay, we're moving into the last application of Pythagorean's theorem, and we are going to apply it to distance formula, really, in the coordinate plane. So, your learning target, you can apply Pythagorean's theorem to calculate distance between points on a coordinate plane. So, the distance formula is in the Pythagorean theorem. When you're given 2 points and a coordinate plane, what I want you to do is plot the points and create a triangle. Okay, so you're going to plot the points and create a triangle. And I'll show you. And your goal is, where's my right angle? How can I create a triangle, a right triangle? So let's plot these first 2 points, 3, 4, and 5, 1. So 1, 2, 3, 4, no, 1, 2, 3. There's my point 3, 4. And now I need my point 5, 1. 1, 2, 3, 4, 5, 1. And I want to know what is the distance between these. And you can't just count diagonals. Now I do want you to maybe make a note for yourself. You use Pythagorean's theorem when it's diagonals. Because think of yourself, hey, it looks like it could be a hypotenuse. Okay? Diagonals means you use Pythagorean's theorem. Don't use Pythagorean's theorem if it's just a straight line. You can count the distance. It would be 1, 2, 3, 4. But you can't count the distance when it goes through diagonals because you don't know that for a fact. Okay, you have to use Pythagorean's theorem. So I'm going to create a triangle, and it doesn't matter if you go down and over or over and down. As long as you make a right triangle, you're going to get the right answer. I'm going to choose to go down and over, and I see my right triangle. So now I have my one side is 3, counting how many unit squares there are. My bottom is 1, 2, and now I can use Pythagorean's theorem to find the distance, the length of this diagonal. So 3 squared plus 2 squared equals the distance squared, or c squared, or x squared. It doesn't matter what you call the variable. So 3 squared plus 2 squared is 13. C squared is 13. And the square root of 13 is 3.6. So these 2 points are approximately 3.6 units across. So again, the goal here is that if you're going through diagonals, you count, or you have to use Pythagorean's theorem. If you're on your homework, you're going to have some problems like this that says, what's the distance between these 2 points? Does it go through any diagonals?
No.
No, so you just count. So it would just be 1, 2, 3, 4, 5, 6. It would just be 6. Okay, so you only use Pythagorean's theorem when you're given diagonals. Okay, next one. Let's find the distance between -2, -3, and 4 and 5. So I'm going to plot the points, -2, -3, 4 and 5. Do I need to use Pythagorean's theorem?
Yeah.
Why? Diagonal. So it looks like a hypotenuse. You just don't see the triangle yet, but you can create one. So usually I go to the top vertex, whatever that top point is, and drop it down to the bottom. So, and I'll do a different color. So I go from the top point, and I drop it down to that base. Now I'm starting to see my triangle form. Connect it, and now I see my right triangle. So the base would be 1, 2, 3, 4, 5, 6. The height, 1, 2, 3, 4, 5, 6, 7, 8. And now I need to find the hypotenuse. So I know 6 squared plus 8 squared is the hypotenuse squared, c squared. 6 squared plus 8 squared is 100. C squared is 100. C is 10. So those 2 points are 10 units apart. Okay, the next application here, you can always use and connect Pythagorean's theorem to a coordinate plane. Meaning if you're given 2 points, you can plot the points on a coordinate plane, connect them, create a right triangle. But you don't have to. If you're just given points, like down here, if you're just given points, and I say what's the distance between these points, you can use this very fancy looking formula. Now this formula looks really crazy, but we've been doing it ever since we started Pythagorean's theorem. Well, actually, just kidding. We've been doing it these first 2 examples. And I'll show you where it comes from. First, maybe I should show you how to read it. Distance equals the square root of x minus x, the second x minus the first x, square it, plus second y, take away the first y, square it. Now I'm going to tell you what that means. Notice here, second x, take away the first x, that's that 6. They're 6 apart. It's just talking about how far apart are the 2 x's. How far apart are the 2 x's? How far apart are the 2 y's? So the 2 x's are 6 apart, and I squared it. Plus, that's right there, 6 apart, squared it. Plus, how far apart are my y's? They were 8 apart, square it. So then I added them together, that's what I got there. And this very big, fancy, long square root symbol is really just saying at the end, take the square root. So do this, and then take the square root of it. That's what we've been doing, just in formula. Now we're going to do it with a formula. So, let's do it. This is the first x, first y, second x, second y. And I'm going to apply the formula. The distance between these two is the square root of second x, take away the first x. So 4 minus 1 squared plus second y, take away the first y, squared. So 7 minus 3 squared. Still doesn't look so pretty, so I'm just going to evaluate some stuff. I'm going to figure out some things. This is the square root of 3 squared plus 4 squared. It's getting better. It's looking a little better. Which is the square root. 9 plus 16 is 25, which is 5. And all this means are these 2 x's are 3 apart and the y's are 4 apart. That's a 3, 4, 5 right triangle. I told you it's the most popular one a long time ago, also known as 2 days ago. Okay, the next one. Then you gotta be careful with integers. So d equals the square root of second x, take away the first x. So negative 4, take away negative 2, square it. Plus second y, take away the first y. Second y is negative 9. Negative 9, take away a negative 3, square it. And then just start prettying it up a little bit by evaluating. That's the square root of negative 2 squared. I wonder if you know where I got a negative 2 from. Negative 4 plus 2, because it's plus plus. Plus negative 9 minus a negative 3 is plus plus. So what's that? Negative 6 squared. Which is, let's see, the square root of 40. 2 squared is 4. 6 squared is 36. 4 and 36 is 40. Then, that is 6.3. Now you do not have to use this formula. It's just there. Some of you are going to be like, sweet, I'm going to use it. Some of you would rather plot the points and create your right triangle. You're definitely welcome to plot the points and create your right triangle. I have graph paper available for you.